Right. Hope you all see my screen, right? Thanks for joining the session, right? So, first thing, uh, so this is basic to advanced performance tuning, right? Uh, so the minimum expectation from so minimum expectations to join this class are like so you should have a basic understanding of SQL Server, at least so the uh, at least SQL basic understanding or knowledge, right? So I believe that you are working as a you all are working professionals, so that it would be easy for you guys to understand so the performance tuning. So I am going in like so the basic level, but I cannot explain like each and everything, right? So if you understand the page, so I it would be easy for us to so go from there, right? So that is the reason like you need to have your basic understanding of SQL Server, so that you should be able to understand or grasp like whatever I am going to uh, teach, right? So the expectation is like that is the prerequisite that I would feel, right? So you should have a basic understanding. If you have a basic understanding of T-SQL, that is way better, right? So if not, uh, that's still fine, right? But you should have a basic understanding of SQL Server, right? So the SQL Server and the components, like whatever, like so SQL Server, SSMS, and databases and all. That is the minimum expectation that is required, right? So and you should have your that is so you should have a proper or your personal system, so that you should be able to start or you should be able to practice on your own, right? So performance tuning, so I can teach, right? So I can teach, but I can guide you like how to start or where to start, right? So the performance tuning is like a ocean. So even if I keep teaching, like I can teach even years together, right? Still, you would not be able to get complete knowledge, right? So until and unless you prepare on your own, right? So that is the reason you should have to have your uh, own system to practice, either like whatever we discuss or whatever we uh, so discuss in the class, right? And so second main thing, right? So might be thinking like so this is completely kind of so everything like kind of real time scenarios, like only the practical or only the like a query performance. Let's say query performance, so I'll just run a query and see the performance and all, right? So if that is the case, you would not be able to understand what is the issue, right? So here the performance tuning, so the more you understand the concept or the more you understand the base, then you should be able to troubleshoot the issue. So this class or the classes that we are going to discuss is combine or mix of theoretical and practical as well, right? So theoretical as in, so I will explain the background, right? For example, let's say SQL Server, how SQL Server works. So I'll explain that, right? So how memory so how SQL Server memory utilization works, right? So the memory architecture. So these all are internals. I will explain. Let's say, for example, you are executing a query, how the thread utilization, threads are actually taking up and executing on the CPU. So that I will explain, so that you will understand if there is any threads are waiting for some resources, or if the session of the query is waiting for some resources, what would happen, right? So I will try to explain, and along with that, and I will show you a few examples, so that you should be able to correlate all these things, right? So along with that, you should practice on your own, so that you will have a uh, better knowledge and understanding in the performance tuning. So I'll try to cover every topic. I'm not going to show you all this, but I will try to cover every topic in SQL Server with respect to performance tuning. And so I will go ahead and explain, right? So we have everything, right? So SQL architecture, starting from SQL architecture, and I will explain like SQL OS, IO performance, TempDB, memory, query performance, and execution plans. Like I'll explain everything that we consider that we have so which would required to understand and learn on the performance tuning, right? So we'll explain, and if time permits, and I will at the end. So I'll go with so new features in SQL Server 22, right? So even in between while talking, so I will start comparing this. For example, let's say you have some um, improvements, right? So let's say, for example, if I discuss any improvements, right? For example, for TempDB. So TempDB, I will talk in 2019, and I will see if there is any difference in 2022, and I'll talk that as well in between, right? So likewise, if any additional features which are not covered in so in the session, so I will discuss them in so as a last topic while discussing 2022 new features, right? So if you have any questions, please feel free to stop me and ask the questions, or right, so you if or you can just make a note and you can ask me at the end of the session, so there won't be any issues, but yeah. And this we were planning for so around um 8 weeks, like that is around 16 days session, right? So 32 hours kind of thing. So but it might go for longer, because the uh, so the concept that we are going to discuss, and so the performance tuning areas that we are going to discuss, it may go for longer. So bear with me and understand, and let's keep learning. We both, right? You and me as well. Go. Any questions before I start, or anything you wanted to discuss? I'll just mute everyone. Like if you have any questions, and please stop me and ask me that I'm there. Cool. First, even I mentioned here, like first I will start with SQL Server architecture, because this is the base that you should be very confident and good enough, right? So on the SQL Server architecture. So that is the first base for any performance tuning that we have. Okay, let me go with SQL Server architecture. Right. So let's go with SQL Server architecture. The reason that we start with SQL Server architecture, if you understand SQL Server architecture, you should be able to understand which component so that we are talking about. Let's say, for example, SQL Server is reading more pages, right? 8 KB pages, right? So where the pages are stored, so you should be able to understand. So that is the reason, like we should have that base. That is just an example. Let's say, for example, SQL Server is generating an execution plan, right? So SQL Server is going for compilations. So from where that is going for compilations, like where the SQL Server actually compile the query. So that and all required to start it. So that is the reason we'll go with SQL Server architecture. Architecture, the more that you understand about architecture, so it would be easy for you to start, so learning performance tuning, right? Cool. So these are the main components of the SQL Server architecture. So there are main components. These are main components in SQL Server architecture. So what are the components? Like we have that network library, and user mode scheduler, right? So we also call it a SQL operating system, starting from 2005, right? So earlier we used to call user mode scheduler. I will talk the detailed discussion why we have a what is user mode scheduler and SQL OS. We'll have a detailed dedicated one session. So I will talk that how that works and how that scheduling works and all, right? So we have a relational engine and the storage engine, right? So these are all main components, and we have something called IO manager, and whereas we have Windows operating system, Windows where the Windows API, so Windows API that we have, right? So we'll talk that what are these all components, right? So now let's say, for example, library, net library. Net library is nothing but a network library that we have, right? So network library that we have. So SQL Server, I'll tell you. Let's say, for example, this is your SQL server, whatever, like this is your SQL server. This is your client application, right? So client application, so communicate to the SQL server. Client has to be communicated to the SQL server. Then SQL server has to respond to the client. Client is nothing but your application, right? Front end application, desktop application, you can call it anything. Like for example, just as for simplicity, like you can consider that it is Amazon, right? Or Walmart, anything. So you have an application which connects to the SQL server and receives like data or confirmation from the SQL server, right? Just say input and output. So everything will be through the network, right? There is something called network. So this communication should happen, right? So how the network, how the communication should happen, right? So this will go here, from this will go to here, right? So this is what the network library will come in under picture, right? So there is a communication between client and server through a network communication, right? So network communication, because SQL Server is always working, three-tier three-tier architecture or whatever it is, right? So we are not going to discuss on that, but yeah. So Amazon, like for example, Walmart, right? So is an application, and it has to communicate with the SQL Server. So how an application communicates with the SQL Server is using the network, right? So this should have a common network to communicate with each other, right? It should have a common network. Either whatever network that you use, you should have a common network. That is what we call it as a protocol, right? So we should have a common protocol to communicate each other and to have a handshake between each other, right? So there should be a handshake. So this one and this one, right? So these two should have a proper communication to connect. That communication is going through the network protocols, right? So the network protocol. The protocol is nothing but you should have a common platform between your SQL server and the application, right? So you should have a common protocol. So what are all protocols that we SQL servers support, right? So what are all common protocol that SQL Server supports, right? So basically we have four protocols, or I would say like, so three protocols like shared memory, second, TCP IP named pipes, right? So these are the three protocols that we have in SQL Server, right? So if I go back here, sorry, if I go back to so the server where you can see where we can see the protocol, like if you go to the configuration manager, any configuration manager matters. Uh, right. So these are the three protocols that we have: shared memory, TCP/IP, shared memory, named pipes, and TCP/IP. Right. So what these three are, right? So we'll talk. So the shared memory protocol, right? So the name itself stating that it is shared, right? Shared between application and the SQL server. Let's say, for example, that you have a computer system like server, whatever, and you have a application and SQL server installed on the same computer. Server and application and SQL server installed on the same computer. So if you have these two installed on the same computer, then the shared memory would work, right? The shared memory, it is using the shared memory. right? So even if these two are disabled or these two are not in use, wouldn't matter, right? Because your shared memory is enabled and shared memory can communicate within the server itself, right? So your application and SQL Server should be able to communicate within the server, right? So without any issues. That is what shared memory is. Named pipes. So named pipes, you can consider it is a local area connection, LAN, local area network. For example, your application, this is your application, and this is your SQL Server. These two are nearby, right? So, for example, let's say it's in a near, this is one building. Let's say, for example, this is another building in the same community, for example, right? So, these two buildings are in the same community or same area or same location, whatever. So these should be able to communicate within each other using the LAN cable, local area network. Or you can consider that it is a your tech park, let's say for example. And this one is your office building one, and this one is another building within the same tech park, building two. So these two should be able to communicate because the LAN is a local area physical connection, right? So you should be able to communicate within within the small area or local area network within the small premises, right? So you should be able to communicate. This is what it is. The named pipes. Named pipes is works. A named pipe also you can consider it as a LAN communication or LAN connection, right? So it's a network, but it is a local area network. So if two servers or two buildings within the same server, within the same location, then you should be able to communicate using named pipes. But let's say you have two servers. One is in India. This server, server one, or you'd say application in India, and SQL Server resides in, let's say, for example, the US, right? So if these two are far away, far apart, then we use the TCP IP, TCP, TCP IP, right? So if these two are far enough, even local connection, even within the same area, that you can use TCP IP. But if TCP IP is used for the wide area network, you can consider it as a WAN communication. If the application and SQL Server are very far or far enough, then we use TCP IP. So that is the reason. So the TCP IP is the more popular protocol we use till today, because TCP/IP can communicate even if these two are two different countries, continents, or wherever that application SQL Server resides on, right? So even if you use that, even Azure, right? So Azure, so where we have the data centers. So the data centers, it can be near or far, like, so we still use the TCP/IP. TCP/IP is a wide area communication, right? So it has some kind of, so the hubs, for example, this is one hub. So how the TCP/IP wide area works, right? Like this is a kind of hub where it is located somewhere, right? Where it has the communication channels, right? Here you'll have another hub, for example. It's kind of extension for your local network. This is another hub. And from this, you'll have the multiple connections to your, let's say, for example, LAN, 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 right? That is the reason you should be able to connect the single point. I mean, you should be able to connect multiple servers, even if there is a very far enough, right? So you are connecting you are connecting all your local connections using a hub kind of thing, right? So you can consider it is an extension for your local area network, right? So obviously, finally, you'll have to connect using the local area. So wide area network is nothing but your terminology or the technology that we are using, because we are connecting a wider area, right? So, but basic thing is LAN. LAN communication should be there, right? So you should be able to connect using the LAN connection itself. But how that LAN communication works using for the wide area network, because with the help of hub. Hub is nothing but you can consider it as an extension, right? So you have extension box, right? So where you plug in, you can extend that to multiple extension box as well, right? So likewise, you can extend the connection or communication if you're using uh, TCP IP, right? So TCP IP, net named pipes, and shared memory. These are three network protocols that we have, right? So next, user mode scheduler. So this is what very important, user mode scheduler or SQL operating system that we call. So we have, uh, for example, you are executing a query, or you are anything you can consider like select, insert, update, delete, whatever queries that you are executing a query. So every query that we are executing, so it has to run on the operating system, CPU, for example, right? So how that those queries has to run on the CPU is decided by the scheduler. So scheduler or SQL operating system, right? So we have Windows operating system. So why we need a SQL operating system? That we will discuss in a detailed session uh, coming up, right? So we will discuss SQL operating system in detail, right? So SQL operating system for now, understand it is a scheduler, or it is one of the component in SQL Server architecture, right? Next important thing, the relational and the storage engine. So relational engine, so we have a different components for you to operate your SQL Server, right? So what does it mean? So relational engine, the name itself is telling. So there is so I mean, in the relational engine, we have a different components, right? So parser is one of the components. So parser, what it does, right? The name itself is telling the parser, it parse the command syntactically, it parse and validate if the command is correct or not, right? If the command is correct, then good enough, right? If not, it will throw an error, right? So that is what it is, parsing, whether the command is the one which you are writing is correct or not. We will talk while taking an example like select and some DML operations that we will take, and we will discuss more in detail how that works, and I'll show you that just an example, right? So it parse and just send that parsing, so query to the optimizer for execution, right? So this is parsing. It checks whether the syntax is correct or not, and optimizer is the one which executes the query. I mean, which so executes. I mean, it compiles the query and generates a plan for execution, right? So then it will go for execution, and then it executes the query, right? So we have something called SQL Manager. In the SQL Manager, we have something called Open Data Source, right? ODS, Open Data
Sorry,
Source. Yes.
please, can you take the optimizer again?
We will talk like optimizer. We will talk in detail, like so we have a complete detail structure. So I just wanted to mention what are the components that we have in the SQL relational engine. We will talk detail. I'll explain. I'll explain. So this is just, so what are, I'm just highlighting what are the components that we have in the relational engine, which components which comes under what. So we will talk that optimizer and parser, and even we'll talk all these components again. So I just wanted to show you that what are all components that we have in individual engines that we have, the relational engine and the storage engine. Okay. So ODS, if I talk, right? So ODS, like I was talking that network library, right? So network library, which communicates to the SQL Server and send communication back to the client, right? So that is going through the ODS. That ODS is a network interface or network port. Any questions?
Is ODS the same thing as ODBC?
Sorry,
Is it the same as ODBC?
OLEDB?
Like ODBC,
ODBC?
Open
No, no,
Database
it is
Connection.
not. No, it is not that ODBC database connection. No. So it is just, so it is an internal point, like it is an internal component which SQL Server uses, right? Let's say, for example, you're executing a query. You are running a query, executing a query. So that query has to send it back to the SQL client. Hello. Okay. So we are executing one query and we need to send the data result set to the application, or the communication happens between SQL Server and the application. So I'll show you here.
Okay, sorry, why I was asking is that in some application connection, ODBC is used, right?
Yeah.
But when
That is
you
just a
talked about net library,
correct. That is just a library or driver that we can consider. ODBC or
okay.
OLEDB and all. But this ODS is different. Let's say, for example, this is your application and this is your SQL Server. And I was talking that application and SQL Server communicates using the network, right? So now, let's say your application is sending something to the SQL Server. Then application will send that communication, and this ODS receives the communication. Open data source. This receives the communication. ODS is the communicator between your application and the SQL Server. You can consider this receives the communication. This is one of the port. It receives the communication and sends to the SQL Server. Likewise, SQL executes the query. It is sending back to that the client. That is also through the ODS output or ODS output, right? Open data source. So we are receiving and sending through the ODS. ODS is nothing but open data source, which is an interface between your SQL Server and the client, which receives and sends through the ODS, right? This is just a, you can consider is a communication channel between SQL Server and the network interface, SQL Server and the application through the network, right? So we have a, so that is a relational engine component that we have. And relational engine and the storage engine will be communicated through the OLEDB communication, OLEDB connection. So this is just like a ODBC. So likewise, like we have OLEDB, which communicates between relational engine and the storage engine. And whatever, for example, relational engine, we are executing one query and which needs 10 pages. So where the 10 pages stored? So that is in the storage engine, right? So likewise, relational engine executes a query which has to write into the transaction log file. So where the transaction log file information will be stored, that is again in the storage engine concept, right? So that is, and you are executing a query, it needs to acquire a lock. Where that lock is acquired, that is again in the storage engine, right? So that is where we have different components. Lock manager will take care of locking behavior, and transactional manager will take about writing into the transaction log file, and page manager, or so even so buffer manager, which takes care of the database pages. And we have different components here. Let's say, for example, you are executing a backup, restore, whatever it is, it will be coming under storage engine, right? Now, so I am executing and one query that is compiled and it is going for execution, and it needs some pages to the, it needs some pages. Let's say, for example, 10 pages it requires. Then those 10 pages we are reading from the storage engine. Then I need some IO operation. Let's say, for example, I want to write the data which is there in the storage engine memory to the disk. then it will come, it will be a IO manager which takes care of. Then we have something called Windows operating system on top of it, right? So we have all these on top of Windows operating system or Windows API that we have, right? So these are all components, right? So even if you don't understand these components, or if you feel that I'm going too fast on these components, bear with me. I will explain each and every component that we have or that we discuss, and we'll show you how that works. That example scenario. One, I'll take select, and second one, I'll take update query, right? How that works, so that you will understand better with the SQL Server architecture, right? So these are the net libraries and user mode scheduler, that's equal operating system. We have a relational engine and storage engine. These two will be communicated to the OLEDB. OLEDB, you can consider that it is a just a driver or communication. Let's say, for example, we have a JDBC driver or .NET library or ODBC, right? So OLEDB. So these all kind of communication drivers between two device, two like you can consider two parties, right? So this storage relational engine and storage engine will be communicated through OLEDB provider, right? Whatever, like non-OLEDB, whatever it is. Then we have something called IS storage engine, and we need storage engine. These all will be in the memory itself. So this is in the memory itself, right? So now this part is completely memory, right? So now even operating system you can consider this is kind of so within the memory itself that it works, right? So now I need some disk operation to be performed. Let's say, for example, the data is resides in the data page, data file. The data file resides in your storage. Let's say, for example, F drive. And if you want to read and write from the device itself, the drive itself, that is where that IO manager works, right? That is where IO manager involves, right? So IO manager is nothing but you are accessing physical disk or physical device, right? So whereas Windows operating system, Windows API, 32 API, like application program interface, where we have everything is on the Windows 32 API itself, right? So these are the components. Now let's understand, so little more. So let's say, for example, you are executing a query. Let's say, for example, you are executing, I would say, this is 2016 SQL Server. So I'm just showing this as an example. So I have 2020, 2022, 2019 as well. And if there is any difference or the features, anything that I need to show you in 2022, I'll show you that as well. Let's say, for example, you are executing select start from anything you can consider that sys processes. For example, this is just an example. And how that works and how this works and what are all protocol, right? So we have and how that works. Let's say, for example, you are executing this from the SQL Server, or you are executing this from the application. This is just an example, sys processes, but example, you can consider that you are executing a select start from table. And if you are executing, this is like a user table and executing how that works, right? We will talk in detail. Uh, Now, let's say, for example, this is your client application, right? So this is your client application that you are executing the query. So I told you the client and the SQL Server will be communicated through the network. That is sure. How they are communicating using the protocol, right? So one of the three protocols, that application and the SQL Server. Application, I will consider that as a client, and the SQL Server as a server, right? So client and server would be communicated using the one of these three protocols. Cannot be communicated with three protocols, right? One of the three protocols, it should be communicated. Again, So this should be communicated using the same protocol. What does it mean by same? Let's say you have a SQL server and application. App, SQL server. So application and SQL server should share the handshake between the SQL server and the application. How the handshake happens between application SQL server if you use the same type of protocols. For example, let's say I have a named pipes. Just an example. I have a named pipes, and if I'm using TCP IP, so I'm not using named pipes. Named pipes is disabled on this computer. And if the communication or the connection is established using named pipes, and if you're using TCP IP, then SQL Server would not be able to respond because SQL Server doesn't understand the communication from the named pipes. It is expecting the same protocol type so that the communication should be established, right? So that is the reason if application using TCP IP, application using named pipes, SQL Server should have to respond using the named pipes protocol itself, right? If you enable named pipes, it will respond using the named pipes. So application is using TCP IP protocol. SQL Server will respond using the TCP IP protocol itself, right? So that is the reason application and SQL server should have the same type of protocol to communicate with each other. Even if you enable named pipe, shared memory, TCP IP, all these three enabled protocols, and you have three applications. Let's say, for example, one is you enable TCP IP, second application you enable named pipes, third application you enable shared memory, right? So these three should be able to communicate because all three protocols that we have enabled from the SQL Server side. So we can enable all three together, right? So if you go here and enable, right? See here the warning. We should be able to enable. There is no issue, but you'll have to restart the SQL Server, SQL services to affect the change, right? So you can just enable and restart the SQL services, right? So if I enable, so you should be able to enable all three protocols that we have, network configuration, and you have to go with the respective service that you are, the respective server that we have on the service, right? So I have enabled all three protocols that is needed, right? So that your application, if you have multiple application and each application has a different protocol, SQL Server should be able to communicate because SQL Server side we have enabled all three protocols, right? So this is how the client and server initial communication happens, right? So we call it as server network interface. This is client side server network interface. This is server side. So we have something called server network interface, right? So we have a client side server network interface and server side server network interface, right? Whatever commands that we are sending, whatever queries that we are executing, right? SQL Server has to get that, like for example, you are executing select query. The select query SQL Server has to receive. But we were talking, this will be through the network. Whatever protocol that we use, this will be through the network. How network understand the select query that we are sending? So select query is some language event, right? So some language. How select query we can send from server to the client or client to the server. The same time, we are generating some result set. Select query, we get two rows, for example, name and ID. And this name and ID has to send it back to the client as a result set through the network. How network understand the data, the plain text or language event. It is in English. So how it understands the language, right? So network would not even understand. So and You no need to network no need to understand anything, because the whatever queries that we are executing here from the client or from the SQL server, it will be sending through the network packets. That is what we call it as TDS, tabular data stream packets, right? So we should send through the network. Network should be able to understand what it is receiving. So how the network would be communicate using only the TDS packet. Whatever packets that we have, whatever queries or whatever data that we have, it will be converted into a TDS packet, table data stream. So you can consider it is a kind of wrapper. So it will be created on top of your data. Anything data you can consider that is a select query or it is a result set, whatever it is just like a wrapper. It creates and convert that into a TDS packet, so that network should be able to uh, understand what we are sending. So we network no need to understand what we are sending, right? Network just receiving the uh, packet. That's it, network packets. And these network packets will be created by the server network interface. Let's say, for example, you are executing a select query. That select query will be wrapped into a TDS packet by server network interface. So server network interface at the client side, it will convert the select event or the whatever queries that we are executing from the client, and it will be converted into multiple TDS packets, right? So TDS packet, each packet size is by default 4 KB. Each packet size by default 4 KB. So we are sending that 4 KB packet through the network. It will be converted that whatever event that we are executing, whatever queries that we are executing, it will be converted as a TDS packet and it will be sending to the network layer. From network, it will send to the respective SQL Server instance that we have based on the protocol that we are using. And TDS packet, and the server will receive the TDS packet. Who will receive? Server network interface, right? So the SQL Server side, we have something called SNI, server network interface, which receives the TDS packet and unwrap the TDS packet into the commands, right? It will unwrap that. So if you unwrap, it is a wrapper, right? If you unwrap, then you will have that actual, the event. Let's say, for example, if it is a select, insert, update, whatever it is, it will be unwrapped by the select, by the SNI packet, SNI interface at the server side. The same thing, if you send the result set, the select query sends 10 rows, right? 2 columns. This will be again converted into a TDS packets, a 4 KB by default. I'll show you that network size, but yeah, TDS packet, and that TDS packets will be sent to the network interface. From the network, it will send it back to the application. So in the application, so we have something called SNI again. So it will unwrap the TDS package and displays the result set. It will send it to the application to display the result set. That is how that works, right? So whatever network communication is through the TDS packets, right? That is what we have it here. Server network interface, and it will convert, right? So I'm just using only one server network interface. You can consider it is a client or application, and sends the query or whatever that we are executing into a TDS packet. And the server side, you have something called SNI, which will unwrap the network packets, whatever TDS packets that we are sending, it will unwrap and it will be sending that language event to the relational engine. Where it will send? It will send to the command parser, because this is a query and command parser has to validate whether the query is syntactically correct or not, right? So whether the query is syntactically correct or not. So it validates, that's it. So it just validates whether the query's syntax is correct or not. If the syntax is not correct, then it will send it back to the client stating the some error, right? So syntax is syntax mismatch, syntax is wrong syntax. Those messages it will send it back to the client. And if the syntax is correct, then it will validate the algebraizer. So what does it mean? I'll show you. For example, you are executing select star from okay, let me take to this database. Select star from person dot person, right? So if I execute this, so we have so this right mark where we have the parsing, right? So it will parse, right? If I just click here, it will parse and says that command completed successfully. The same thing, if I execute this, select star from person dot person, right? So person dot person. So you see here the red mark out there, it is what we have. The keyword is something missing, right? This is what we call it as a syntactical error, right? If I just parse this incorrect syntax, right? This is what it does by the command parser. It validates whether the syntax is correct or not. That's it. So it will validate whether the syntax is correct or not. If I, let's say, for example, from this one, though we have a red mark highlighted because it says that invalid object name, but it is not an issue with the syntax. Syntax is only if any of the keywords with SQL Server understandable keywords are not correctly mentioned, correctly entered, right? Those are all called syntactical errors, right? So let's say, for example, you are executing this one. This is syntax error because uh, we we are missing to get the columns. We don't have a columns to get the data, right? So this is what it is syntax, right? So syntax is nothing but SQL understandable keywords are not properly specified or not properly mentioned. Those are all syntactical errors. If I take this, it is not syntax error because the table doesn't exist, will not validate by the query parser. It will not be validated by the query parser, right? So if you just compile, try to compile, right? So this is just, if I see that estimated execution plan, we will talk that estimated plan and all. Don't worry. Just if I try to do this and it gives an error saying that invalid object. So it will not. Now, so this is what the syntactical validation would be taken care by the query parser, command parser. Now syntax is correct. Now this one, if I execute, okay, select star from person, right? So select star from person. Okay, 1 second. Okay. So now, can anyone tell me like these two are same or different?
They are different.
Different, like why?
The schema is different. One is using default schema and the other one is using person schema.
Right, cool. Thank you. Yes, correct. So this is using person schema. This is using default. That is your DBO schema, right? These two are two different queries, right? So how this will validate whenever you execute a query? So how SQL Server understand, right? So this is, so taking this person schema and this DBO schema is because it is doing the schema binding, right? So schema binding. Who will validate the schema binding? Again, it is using the command, it is by the command parser. We call it as a algebraizer. Algebraizer is nothing but it will validate whether the schema is properly bound to the particular table or not, right? So either it is a DBO schema or it is a person schema, sales schema, whatever schema that we use, right? So it will understand the schema binding, everything will be taken care by the command parser, right? So the command parser, it will validate the syntax is correct or not. If the syntax is correct, first validation is syntax is correct or not. If the syntax is correct, it will check the schema binding. That will be taken care by the command parser. So once the schema binding is done, then it will create a query like tree. For example, let's say you have a 10 tables joined together, right? So how that SQL Server, for the simplification, this query command parser will create a tree-like structure, right? So kind of tree that it generates. For example, if I take this, let's say, for example, this is root, whatever, like, so tree-like structure, it creates. No, this is just a rough uh, picture diagram, right? So you can consider that. So it is just like a tree-like structure where you have the select query and you have the table T1, T2, whatever joins that we are using. So everything it will be creating that. So the entire query will be divided into a smaller pieces or smaller, uh, smaller, it will divide into a smaller pieces and it will be creating a tree-like structure so that the optimizer can easily proceed further, right? So for that reason, it creates a tree-like structure and send the tree to the query optimizer, right? So then query optimizer receives the tree-like structure and try to derive the, so try to compile the query, right? So first, what optimizer actually does, I will tell you. So this query tree will be sent to the optimizer. Optimizer receives the query tree. So based on tables, based on the commands, based on joins that we have. So what optimizer does, optimizer first part is to validate whether the plan is available or not, right? So what does it mean by plan? I will tell you. For example, let's say, take an example. You are constructing a house, right? We are constructing a house. If we are constructing a house and we have an architect, we have a builder, we developer, someone like, so let's say, for example, we have an architect, right? Who creates a design for our building. Let's say, for example, you are constructing a house within uh, one community. Let's say within one uh, project. Let's say, for example, it is a one project. Uh, Architect has to design the construction plan. Now, let's say, for example, architect already designed a plan for one house construction, right? So he has a plan. Second house, to construct the house, right? So, for example, let's say it took around 10 days to construct a plan, right? So 10 days to construct a plan. So then everything he gets gather the data, right? For example, let's say 10 days and some amount, right? 100,000, the value, right? So how many days, how many you can consider like workers required to construct the house? Let's say, for example, 100 workers required, right? So these are all estimates. Based on this estimation, he created a plan. He will not construct, he created a plan. So this plan will be shared to the, so the developer who develops the project, right? That is second part. First, he creates a plan based on different so metrics or different uh, things together. He creates a plan and the plan will be stored. So the plan is stored because if I want to construct the similar house again, so if architect has to design for the similar house construction, he no need to spend some time to design again, right? Because he spent almost a week to create a plan, and he no need to spend another week to create the same house construction plan, right? Instead, what he can do, he can take the same plan that it was created, and he can use the same plan for house construction. So if it is a different construction, that altogether is a different story. If it is the same kind of construction that he's working on, then he can use the same plan so that he can save this 1 week time, right? So the same thing applies to here, SQL Optimizer. So SQL Optimizer, it creates a plan. So SQL Optimizer, it creates a plan, execution plan. So before we create, it creates, how it creates, I'll tell you. But just for understanding, before it even creates a plan, it validates whether the existing plan already available or not. So where that plan stores, that is where stores in the data, stores in the storage engine. We call it as a plan cache, part of storage engine, right? So storage engine which stores the data. Either it can be a plans, it can be a data, whatever it is, it stores a plans in the memory itself. All these are in the memory itself, except these two, all are in the memory itself, right? So now optimizer, query tree sent to the optimizer. Optimizer will check whether the plan is available in the memory, already a plan is available in the memory or not. If it identifies the plan, this plan can be picked up and go for execution. Let's say this plan is not valid, right? Whatever reason, the plan is not valid, then so if the plan is not valid, then optimizer has to generate a new plan. The same thing, the house construction, right? The architect has to create a new plan for execution, right? So optimizer has to generate a new plan. So how optimizer generates a plan? So optimizer is, so you can consider it as a cost-based optimization. Let's say, for example, you're executing a query. So within a few seconds, optimizer will check like hundreds of thousands of the, so permutation and combinations to generate a plan, right? So if it identifies, right, within the, so within few uh, checks, if it detects the optimal plan for this execution, then it stops the further optimization and generates a plan for that, right? So optimizer is not a is not looking for a best plan ever for this particular query, right? So let's say, for example, a query you're executing and optimizer thinks that this query can execute within 30 seconds. So optimizer detected this query can execute 30 seconds. So it generates a plan accordingly, but it will not keep searching for or so checking the plan which executes within 10 seconds. Because let's say, for example, the optimizer generates a plan in 1 second, and the execution time it takes would be 30 seconds. So total 31 seconds for compilation and execution. Now, let's say, for example, if it thinks that 36 would be more, and if it keeps searching for best plan, maybe it is 10 seconds, let's say. But to get this plan, optimizer took around 45 seconds to generate the best plan for this query ever, right? So 45 seconds it took. Then 45, 10 plus 10, 55 seconds to execute the query. So this is way more than what we have this here, right? So this one, optimizer finds the better plan, finds the plan which is optimal plan for this execution, for this query, and then stop further optimization. If it cannot, if it keeps going further, right? So even though if it detects that optimal plan, if it keeps going, then it takes longer time than stopping here. So that is the reason optimizer is always based on the optimal plan for this query execution. It will not wait for best plan for the query to be generated, right? It will not search for best plan. It is search for optimal plan for this query to perform, right? So that will be optimizer responsibility. Now, optimizer, how this generates a plan, right? How this generates a plan. So how this validates, I was talking that various permutation and combination, right? What those are, like how the optimizer generates a plan. So optimizer, first thing, it will check the query is simple query or not. What does it mean? If the query is simple query, let's say for example, there is no joins, there is no weight clause, there is no multiple tables involved and all, like it is considered as a trivial plan. So then optimizer will not go for further optimization, and it detects that it is a trivial query or trivial plan, and it stops for optimization then and there, right? So I'll show you that. Just don't worry about the execution plan and all, like I'll explain detail, but just for select star from person, right? So this is just a simple execution, simple query. If I execute this, this gets some data, right? So we are getting some data because I think I restarted. So that is the reason it is taking time, right? If I go here, XML plan, see here, statement optimization level, right? So this is a simple select statement, simple query. So that is the without anything. So it is optimization level is trivial. So optimizer would not go further optimization. It identifies that it is simple query. So I'll stop here. I don't need to go for optimization, and I don't need to go for further optimization to generate a plan, right? So that is what it does, right? Simply it just stop the further optimization and generates a plan for the query execution, right? So if the query has some joins, some weight clause, like on some parameters and all, then it will go further in a different phases, right? The full optimization happens in a multiple phases, right? Let's say, for example, phase one, phase zero, for example, like it performs in phase zero, phase one, phase two. In the phase zero, it checks like what are all tables which are involved. So tables involved, and whether we have any joins or not, right? So how many tables are there and how many what joins that we are using, right? First, based on that, it will go for optimization, right? It will check whether the table has if the query has multiple tables and what joins that we have. Second thing, second phase, it will check what are all so indexes that we have. So based on the indexes or statistics, right? It checks the indexes and statistics.
Incoming call from
One
XMEX
sec.
Walmart WM.
So it checks like if there is any indexes on the tables or not, right? So it will validate the indexes and the statistics that we have, and it generates a plan further optimization based on that. If it based on the indexes and statistics, it generates a plan. First, based on the tables, it go for further optimization, and second thing, it will validate the indexes that we are using, right? So indexes and the statistics of the tables that we are executing. Third phase, right? So it will validate whether the cost of this particular execution is more than what we are expecting to. Let's say, for example, the cost of the operator is more than 5. For example, cost of the operator is more than 5. Then it thinks that, okay, the cost is more, then I should go for parallel execution, right? So that also in a different phases, right? Phase zero, it checks what are the tables that are involved and what are the joins that we have. And based on that, it generates a plan. Optimizer generates a plan. Second thing, it based on the tables, right? So based on phase two is including phase one plus phase two. Phase two, it checks like what are all indexes that we have, and how much data we are, what columns that we are pulling, and what are the indexes that we have, and statistics on the tables, right? So whatever statistics that we are we have on the table, and based on that, it generates a plan. Third phase, or phase two, phase zero, phase one, phase two, and it checks the cost of the operator, cost of the execution. If the cost is more than like either 2, 3, 4, 5, whatever it is, it checks that whether the cost is 4, 5, for example. More than 5, then the query go for parallel execution. Then optimizer generates a parallel plan, right? So based on these phases, it generates a parallel plan of the query. For example, select star from person. Let's say, for example, join person phone on p dot. I'm just joining a simple join condition. You don't need to worry what I'm writing here. Just wanted to show you where business entity ID equal to 100. Let's say, for example, and I'm generating a plan. If I execute I got some data and we have some results set like joins and all. And if I go here and optimization is full, statement optimization is full. Earlier, statement optimization is trivial because it is just a simple select statement without any joins, without any weight loss, nothing. So this is a simple statement. So it considered as a trivial plan. So optimizer would not go for further optimization to get the plan, right? It is just simple. It identifies the trivial plan and immediately it generates a plan. But if it is a full optimization, so it is going further optimization level that we were talking, level 0, level 1, whatever, phase 0, phase 1, I was talking. It validates all these to get the plan, right? To generate a plan. That is how the optimizer generates an execution plan for our query. Right, you no need to execute the XML plan. So even if you go to the properties of this, right? So right click and properties of this particular, and you will have that information here. For example, see here, optimization, I just selected on select. So where we can see optimization level is full. We will talk that more in detail, like, so in the execution plan, don't worry. Just wanted to show you because I'm just keep showing that in XML plan. You might think that only it is available in the XML right now. So you can just, if you want to see or read through XML plan, right click and show XML, show execution plan as XML. But don't worry what we were talking, right? So this is what the full optimization that takes care by the optimizer, right? So once this identifies either it is a full optimization or trivial optimization, so it generates a plan. It compiles the query, right? So it compiles, right? It compiles a query and generates a plan. So once the plan is generated, this plan will be stored again in the memory. That is your plan cache area, right? So the plan will be stored in the plan cache so that it can be reused. And now the plan is generated and sent to the query executor. This query executor is actually executing your query. That's it. So query executor start executing the query, right? So then what will happen? This query needs some data. Query needs around 100 rows. This query execution, obviously, right? So while executing a query, let's consider it is a select statement. So select query requires 100 rows. So where the data is available, the data should be available in the storage engine. That's what we were talking. Relational engine just is a, so the logical. So whereas storage engine, so the data would be stored. Then query executor needs data from the storage engine. Then it will be communicated to the storage engine through OLEDB provider. Right? This is the OLEDB communication. It establishes a connection to the SQL server. So in the storage engine. In the storage engine, we have something called access method. So access method you can consider is a communication channel between relational engine and the storage engine. This is the connection established. As soon as the connection established, it has to have some communication channel, communicator, right? Who is the communicator? Is the access method. So it receives the request, right? It needs 100 rows. Then access method, it will pass that information to the buffer manager. So leave that piece for now because we are executing select statement. Transaction manager would not come into the picture for now. I'll talk that later. But for now, understand that access method send that communication to the buffer manager. So this all again in the memory itself. Buffer manager, what it does, it will check whether the requested data is available in the memory or not. So where it checks the data, it will communicate to the data cache. Data cache is the place where it stores the data pages, right? Your data or index pages. You can consider that pages, 8 KB page. So where 8 KB pages are stored, the 8 KB pages are stored in the data cache, right? So this is what we call it as a buffer port. It is just divided, but where we have the data cache or where we have that pages is stored in the buffer pool, right? So buffer manager, it checks whether the pages available in the data cache. If the pages are available, let's say this 100 rows uh, spread across 10 pages, let's say for example, fit into 10 pages. Then I need 10 pages because SQL Server, we operate in like whatever data that in the pages as well, pages only, right? So this 10 pages data, we have 100 rows in the 10 pages. Then SQL buffer manager, it checks whether these 10 pages available in the data cache or not. Let's say 10 pages are available, then it reads the data, send that information to the access method. Access method send that data result set to the query executor. Query executor will send that result set to the protocol. Query executor will send that result set back to the uh, client through the protocol layer, that is server side protocol layer. Then this server side protocol layer will convert this result set into the TDS packets or TDS packets and send it back to the client, right? Got my point? So if the pages are available in the data cache or the memory, the buffer manager will read the data and send it to the access method. And access method is the communication channel between relational engine and the storage engine. Then it will send it back to the query executor. Query executor receives the data and send it back to the client through the protocol layer, whatever protocol that we have. And how the data will be sent it back to the client through the network, through the TDS packet. So how the TDS packet will be converted? Who converts this data into a TDS packet? That is your SNI library, server network interface library, which converts the result set, that is 100 records, into multiple TDS packets, right? So 4 KB TDS packets, and it will send it back to the client through network by TDS packet. Let's say, for example, pages are not available in the memory, right? The pages are not available in the data cache, right? So if pages are not available in the data cache, then the buffer manager will send a request to the data file. This only takes care of that. This buffer manager send a request to the data file and requesting for the pages which are not available in the memory. Let's say this memory, we have 8 pages, for example, and I need 10 pages and 2 pages are remaining. And these 2 pages, buffer manager will send a communication to the data file and requesting for these 2 pages. Then these 2 pages will be retrieved. I mean, the data file, it pulls the 2 pages from the data file, and the buffer manager will not directly send that to the query executor. These two pages will be stored in the data cache, right? So the data cache, it will be stored. Then the data or result set will be send it back to the query executor through access method if the pages are available. If pages are not available, then it will connect to the data file and it will pull the pages and keep it in the memory itself. That is data cache. Now, when these pages will be removed. So when the page will be removed, right? So if the page, I was talking, right? The pages might be available in the memory. When the pages would be removed, there are two reasons the pages would be removed. One is if there is a no enough memory, right? So if you don't have enough memory, then the page would be removed from the cache or data cache, because you will have to accommodate few other pages as well, right? So if you don't have enough memory to accommodate the pages, other pages, then you will start seeing the queries are waiting for this memory to be available, or the queries are waiting for the pages to be writing into the memory, right? So you don't have enough memory, then the pages will be flushed out of memory. Second thing, you are doing is so much operation, right? You are doing huge operation. Let's say, for example, you have a 1 TB database and you have 100 GB of memory. Again, it comes under the no memory concept only, but you are doing so much data, so much operations, right? So this entire data cannot fit into this 100 GB, right? So if you are doing high operations, it has to read from the data file itself, right? So whenever you are reading so much data from the disk, doesn't mean that you don't have enough memory. It can be an issue with your operations that we are performing, right? So, but yeah, that we will talk later. But for now, just understand whatever pages which are there in the memory, then your buffer manager will read that pages data and send it back to the client. If not, then it will read from the data file, right? So when the pages would not be available, if there is any memory issue, or if the page is, if you are doing a high read operation or high write operation that you are performing, then the pages would be then you will have to keep writing into the data cache or keep writing into the data file. So this is how the select query works. Any questions so far on this select? We will talk about transaction manager. So we have something called log manager and transaction log file and all. We will talk in the DML operation. That is insert, update, delete, whatever you consider that. Any questions? I hope this I cleared in the optimizer piece. Someone asked me, like, in any other questions? Any questions so far which are not clear, or if you want to understand more?
My question is on the access method.
Right.
From your diagram, right?
Mm-hmm.
The trivial plan, the optimizer goes directly back to SQL Server.
Mm-hmm.
So when it's using the access method, that
Okay.
means basically it's using like indexes.
No, access method is just an internal concept which takes care. It is just a communicator. For example, let's say it doesn't do anything. No, nothing, right? Even indexes, nothing. It doesn't do anything. Whatever data it is receiving between these two. For example, query executor, it is requesting some pages to get the result set. So that information, it will be sent to the access method, and the access method will communicate the same thing to the buffer manager. At the same time, so we get the data and we are sending that information back to the relational engine. How that information will be sent? Through the access method. It's just a communication channel, so which internally takes care by the SQL Server. So this is nothing to do with the indexes, tables, nothing. Right? It's just a communicator.
Okay, this is storage engine, right? Now, this is the storage engine is different from relational engine. Storage engine is basically where we have the disk and all that. Now, for optimizer to go for a query plan, if it gets a query plan and it's a trivial plan, so look at the graph, look at the diagram, look at your diagram. Now, after the CMD parsing, making sure that syntax are okay. Now it gets a tree, it forms a tree, comes to the optimizer, now creates a query plan and goes back to SQL Server. Now, if he has to come to the storage engine, which it connects with the JDBC, OLDBC, any of those. Now, if it's connecting the relational engine with the storage engine, that means it did not get, I don't know if you understand what I'm saying. It didn't get the query from the query plan that allowed it to go to the storage to look for it. So that means, that's why I use the word indexes. Probably, I don't know if you understand what I'm saying. There are some kind of things that is required for it to get that query from the storage. So it's more expensive going there, coming down to the storage.
So, expensive as in like going back to the data file you're talking about?
Yes, because it has to go down to get the query back to SQL Server. So that's why I'm asking. So for you to use access method, that means there are other things that is doing, because this is a storage engine. It's communicating with the storage, and this is disk. That's why it's picking it up. So I'm a little bit confused at this point. Is it making like an optimal full plan, or the first part is the first part just a trivial plan, and the second part, because it has to go deeper to get the file, is it going to be like the third plan?
Okay, 1 second. I think you covered so many, so all mixing, right? So just trying to understand or correlate what we are talking, right? So see, so this oil, 1 second. So access method, I don't know like how to put all together. So let's see, OLUDB, like communication to the access method, and access method is communicated to the buffer manager, and buffer manager will be communicated to the data file if the pages are not available in the data file, right? So access method is nothing to do with whatever that we are performing, right? So access method is anything, like even if it is a trivial or if it is a full optimization, doesn't matter. Like it is just a communication to the storage engine and relational engine, even if it is a trivial plan, and if it has to communicate to the buffer manager, even if it is a DML operation, let's say for example, insert, update, delete, anything. So it has to be communicated to the communicated through the access method and communicate to the buffer manager, and the buffer manager will communicate to the data file. So what is the confusion here now?
I can't even hear you very well because it's kind of faint.
No, I can believe
Your voice is faint.
Oh, my bad. So can you hear me now?
Yeah, it's better now. Yeah.
No. So what? Okay. So I don't know where I lost you guys. Okay. So what my point is, like either it is a trivial or it is so full optimization. The query has to go through this access method and get the result set. So access method is just internal structure or internal. You can consider that internal object which takes care of that. It is nothing to nothing related to any of the queries or anything. So either it is a trivial or full optimization, whatever it is a internal structure that we have, and so which communicates to the buffer manager. or even if it is a transactional manager, if it comes under any DML operation that we are executing on. So my point, like, what is the confusion here? Like, if it is, so on confusion on the access method, if it is a trivial or full optimization plan.
Yeah, I'm looking at that. If it's a trivial, no, I know the I'm looking at the trivial from the first part because it just went through. Look at the arrow. It came from the TDS, right? There was a parsing CMD. They check the syntax. Optimizer, the work of an optimizer is to check the query plan, see if it's there, just like you said. Now the query executor. Now, if it does not find the query, what happens? It looks for other means to go to the storage. Now, if it comes to the storage, that is why we have the access method. Now, the access method gives us options, where to get the query. From the diagram, it comes to the buffer manager to the data file. Now, for it to go to the data file, that is expensive. The query will be expensive. That's why I'm thinking you have the full optimized stuff up there, the last time. So I don't know. That was why I'm confused. I need to understand that part.
No. See, okay. Full optimization is nothing but like, so you have, like, it is not a trivial, right? So trivial is just a simple plan or simple query that you are executing. Full optimization, if the query has multiple join conditions, operators, where indexes, statistics, everything SQL Server optimizer detects, then it will go for full optimization. So in that full optimization, doesn't matter either it is a trivial plan or full optimization. If it is going for data file or storage itself, it is an expensive. That is for sure, right?
That's what I'm saying. So for us to use access method, my thing is this: for us to come to the storage, the query is expensive. Now, for us to have the first part, relational engine, the optimizer, that means it went to Celesta, is able to pick up the plan immediately and execute. Now, for it to come down, for the access method, this is a storage. This is clear. Storage engine. For it to come here using this access method, there are different ways you can access. Access method, what's the need of the index? You're creating that. Anyway, continue. Don't worry.
No.
No,
So,
I mean, so maybe let me just, maybe I'm not understanding very well. I think from what he said, if I'm correct, when it comes to the access method, I think it goes first to the data cache to see if if it has, yes, before it's when you don't have it there, before it now moves to that expensive query, which is the data file. I think that was what he earlier explained, if I'm correct.
Which is storage, yes. Max, you're correct. I think what Ona is asking is, I think he's confusing it. What he's trying to say is would require if he doesn't, they say that when he's not in the data cache, that means that it needs indexing. But
Yes,
if the data is not, if the data is not the memory, it is not there, whether you have the right indexes or not.
Yes.
It still has to go and get it from storage if it is not there.
Yes, definitely.
Right.
Yeah, you're making my point. Now, if he has to go to the storage, that's why he's going through this access method. You understand?
No.
Because access method is just the link.
The diagram,
access method does not
showing
mean
that it will go
expensive.
through the access method regardless, whether it's going to the
memory, whether it's going to go through it
or the storage.
Yeah.
Okay.
Yeah. That is what, right? So access method doesn't matter whether it is nothing related to your queries that you are executing, right? So access method, again, so it is just a communication between your SQL Server storage, relational engine and storage engine. It just communicate here and go here and check whether the data is available in the memory. If not, buffer manager, go back to the data file and gets the data. So it doesn't matter whether you have an index, don't have an index, or doesn't matter whether you have it is a trivial or it's a complex or full optimization, doesn't matter. So it will just connect to the access method and connects to so various components from there. Is it clear?
So the access method does not perform its operations. It's been taken care by the buffer manager. Access method will ask the buffer manager to retrieve the page so that it can prepare the OLEDB row set to pass back it to the relational engine.
Precisely. Like, So say access method doesn't do anything. So it just say you can consider it as a communicator as a high level thing, right? Like it is just it doesn't do anything. So and you no need to worry what query that you are executing. It will still based on so if the data is available, then it will go for memory. Otherwise, it will go for database. That is taken care by the buffer manager. But access method will send that information or notification to the buffer manager.
I think can do all the things, indexes, scanning, seeking, all the things are decided in optimizer itself. So the access method is not come in the picture. Access method only role is to play with the data, where is data residing, and pull out the data.
Yes. But access method doesn't do anything. Like again, I said, like it is just a communication channel. You can consider it as a high level. And whatever the plan, if the plan is generated, right? So if the plan is generated, that is where, so we use that indexes, statistics, everything, right? So then
Yeah,
it
I
will
think
go
this
for the query executor, and query executor will communicate to storage
I,
agent using access method. Yes.
I think this is it is a mediator only thing. Only passing, taking
Yes.
the input and passing the output.
Yes. Right. Is it clear?
Yeah, I understand, but I probably may have to study a little more about it.
Uh-huh. Sure. Anything specific? Uh-huh.
Oh, so I have another question actually about the trivia plan. So you are familiar with first responder kits, right? So when I use this Brent Ozer's first responder kit and do SP_bliss cache, it identify so it will identify like top resource consuming query, and usually it identify trivia plan as one of the reasons why I have this top resource consuming query. So I used to think that trivia plan is something bad, right? But from what you explained here, sometimes if you're just doing something very simple, like a very simple select star with not with no serious thing in the predicate, then you're likely going to have a trivia plan. It's more or less like it is what it is. It's not like really it is a bad thing to have. Is that a correct understanding? Or
correct. That is correct understanding.
Yeah. So why does it come up in a top resource consuming query when I do it in SP_bliss cache? Any idea?
Okay. So if it is a trivial plan, right? Trivial plan, that trivial plan can have that, let's say, for example, simple index scan or table scan. Just give a minute. Okay. So sorry for that. Like even if it is a trivial execution plan, the plan can read a huge amount of data. For example, let's say it is going for table index scan, right? So if it is going for index scan, right? So even if it is going for, let's say, for example, from person dot person, right? So if I take this, or just I use this person, if I take this take 2 seconds to get the data, right? 3 seconds to get the data, right? So though it is a trivial plan, it is reading the complete table, right? So I don't have any index, I don't have anything. If I go here, XML, so it says the trivial plan. So though I'm just, so it is a trivial plan. So it took 3 seconds, is not easy, right? So not a simple thing. If I take the same thing, set statistics IO on, right? So if I get the same query, so I will talk this, like, don't worry, what this will tell what are the how many pages that we are reading. And we are reading almost every page that we have, right? So 3,809. So we'll have to see like what exactly it is doing. Like even if it is a trivial plan, there are chances that the query is running for longer. And at the same time, the query might be requesting more pages to get the data or writing like, so it's a even the plan is trivial, but whatever the operation that is performing, it might be complex, it might be huge, like this. Like we are reading almost every page that we have. or you don't have a proper indexing, right? So that also can be one of the reason for, even if you see the trivial plan, it might go for, so expensive.
Okay, thank you.
Sure. Cool. Right. So any confusions, any questions, anything? So I'll just so a recap a high level. Maybe we'll see that, right? So you are executing a query. It will be converted as a TDS packet because network has to understand what we are doing, and the TDS packet will be sent it to the so SQL Server. SQL Server unwrap this TDS packets in the server network interface library. So the unwrapping the whatever TDS packet that it is sending from the client, right? Once the TDS packets are unwrapped, and it will be sending. So it identifies the language event, SQL understandable language, that is T-SQL, and send it to the command parser. Command parser, it checks whether the syntax of the query is correct or not, right? If the syntax is correct, then it will be so doing a algebraizing, that is your query schema binding, and the schema binding is validated, then it will create a query tree. So query tree is basically, so simplifying your query. It will be creating a tree like structure, and send it to the query optimizer. So optimizer, it checks whether the plan, before creating a plan, it checks whether the plan is available in the memory or not. That is where your plan cache comes under, right? So again, these all in the memory itself. Memory, though these are in separated so places, like you just read, this all comes under memory itself, right? So don't confuse. Optimizer, and optimizer will check whether the plan is available or not. If the plan is available, this plan will be picked up and go for execution. If the plan is invalid, or if the plan is not available, then query optimizer generates a plan, right? So how the query optimizer generates a plan? So based on various optimization levels, right? First, it checks whether the query is trivial or simple query or not. If it is simple trivial query, then then and there it stop further optimization and consider it as a marking it as a trivial plan, right? Then full optimization, it checks various phases, like whether the query has multiple joins, whether the table has indexes or statistics, and further, like so it checks whether the query cost is more than so the cost we define, like cost of the query operator, then it go for parallel execution. So all these will be considered and generated a full optimization plan. Once the plan is generated here, then it will send the plan for query execution, right? Once the query execution started, so it needs some data to be retrieved. So that data will be, so that data would be stored in the storage engine, right? So the storage engine, it has to be communicated. How relational engine will communicate to the storage engine? Through OLEDB provider. This is a library, or this is a driver which communicates between relational engine and the storage engine. So how this will be communicated? Through the access method. Access method is an internal structure which uses in the storage engine for the communication between buffer manager and the sorry, so you can consider that access method is the communicator between storage engine and the relational engine, right? So you need 100 pages or you need 10 pages, whatever data you require, the access manager will send the notification to the memory manager to get the data. So memory manager will check whether the pages or data available in the memory or not. Memory is nothing but data cache, right? Or buffer pool. So if the pages are available in the memory, so buffer manager reads the result set and sends the result set to the access method, and access method will send it back to the query executor. Query executor will send the result set back to the protocol layer. Protocol layer will convert the results into the TDS packet, and TDS packet will be sent it back to the client, right? If the pages are available in the memory. If the pages are not available, right, whatever reason, and then it will read, the buffer manager will request the pages from the disk. That is what we call it as IO operation happens on the storage, right? So then it will read the pages and by the buffer manager, and it keep that pages in the data cache again. So it will not read directly from the buffer manager. So the buffer manager will place that pages in the data cache or a memory, and then it will read that, it will send the result set back to the relational engine or query executor through the access method, right? So query executor will send it back to the client through the TDS packet. This is how the high level this select query works. Now let's understand some DML operation that we are performing, right? So DML operation as a like update query. Let's say, for example, you can consider that insert, update, delete any query, so which works in the same way, right? So let's consider that update you are doing, right? So update is the most complex, I would say, right? So then delete or even insert. So update query that you are executing, this update you need to write into, okay, let me put this way. Where is that? Okay, so until this piece, right? So until this access method is common, right? For update query, right? Until this access method is same for even update query or DML operation that we are performing, right? Now, so while updating some data, right? So we are updating something. Let's say, for example, 100 to 200. If I want to roll back the transaction, so I have to roll back properly without any issues, right? So I have to roll back without any issues, right? I'm just updating 100 to 200. For whatever reason, I want to roll it back to 100, right? So how you should be able to roll back the transaction? Because if the transaction is available in the transaction log file, right? So the transaction log file will make sure whatever transactions we are performing is available in the transaction log file, right? So that will be taken care by the transaction manager, right? So transactional manager will take care, will make sure the transaction is written to the transaction log file before even writing into the data file, right? So transaction manager will make sure that the transaction is written to the transaction log file. Whatever operation that we are performing is written to the transaction log file is before even writing that into data file, right? So then your recovery would be consistent, right? So if you're writing that into the data file, but the transaction is not available in the transaction log file, what would happen, right? So during the recovery, the SQL server has to identify what needs to be undo, what needs to be roll forward. So that information would be stored in the transactional log file. So that is what we call it as a write ahead logging, val concept. Write ahead logging is nothing but writing into the transaction log file whatever operation that we are performing, writing into the transaction log file before even writing the data into the data pages, right? So that transaction manager will take care of that. Let's say, for example, you are doing some modifications, update. So if you're doing update, access method will receive that request and send it to the transactional manager, right? So send it to the transaction manager, and transaction manager write that into the transaction log file. At the same time, so access manager will send that information to the memory manager and write that pages into the buffer pool, right? That is a disk data cache, right? So we call it as a dirty page. Dirty page is nothing but the page in the data file is different or modified in the data cache. For example, you are reading some page, right? So let's say, for example, you have 100 page number, and the same 100 page number you have it here, page number or value, whatever it is, you can consider that 100 page you have a 10 value. So 100 page you have 10 value, right? These two are same. Now you are updating something from 10 to 20. Same 100 page, you are updating to 20. So what it happens, like you are doing a modification update. So that information will be stored first in the transaction log file. So it will write into the transaction log file At the same time, it will write that into the data cache as well, right? 100 into 20. It will update that 100 into 20. 100 paste and 20 record, right? So it has this 100.20, the value updated to 20. So it will not write into the data file immediately, right? There are some operations, I will talk that later. So for now, understand that. So it will not write into the data file. So this is what we call it as a dirty page, right? So the page which is there in the data cache, that is in the memory, is different than the page that we have in the disk data file, is called dirty page, right? So whatever operations that we perform in the SQL Server DML operation, it will write that into the transaction log file first, right? Write ahead logging. This write ahead logging, then it will be make sure that the transaction is durable in the transaction log file. So that is your ACID properties. We will talk ACID properties later. So, but D for durability. Make sure that data transaction is available in the log file so that if there is a crash happens, I should be able to recover the data, right? So it will write into the transaction log file. Now we have two parts here. I would say like log manager and the log manager. Log and the log, right? So log manager will take care of writing into the transaction log file, whereas log manager, until the transaction is completed, the log will be held so that no other transaction can access the data or access the resource, same resource that you are executing. Let's say, for example, select and you are selecting the data and you are updating something. And if you're doing same thing, then there will be a conflict or inconsistent data, so that when you updating, so no other transaction can select. So that is where you are managing the consistency of data. So that will take care by the lock manager. Lock manager will make sure that you have a proper locking on the operation that we are performing, right? So the transactional manager, it will make sure we are writing into the transaction log file so that whenever there is a crash happens, so I should be able to retrieve the data. I should be able to recover the data, which is required to make sure the data is consistent, right? That will take care. Once it is written to the transaction log file, and the same time we are writing the dirty information or dirty data to the so the updated data to the page, that is what we call it dirty page, right? Because we don't have the same page available in the data and data file and the memory, right? Now, so when this data will be written to the transaction log file, right? So there are two concepts. I'll show you that just a moment. So let's say, for example, you are doing some operations, right? So this is your SQL Server. This is your transactional file. And SQL Server, you are performing some operations. This is your SQL, and you are performing some insert or update or delete, anything. So would it immediately write into the transaction log file? No, it will not write into the transaction log file. So what will happen? In the memory itself, so we have something called log cache. Log cache, right? It will write into the transaction, like whenever you perform any DML operations, it will write into the transactional log cache. I mean, not before writing into the transaction log file, log file. This is your disk, right? So you can consider this is some I drive. This is your I drive. Right? So you are doing some DML operations, and those generate some transaction logs, right? That will be first written to the transaction log cache before writing into the disk, because Again, continuous writing into the disk is kind of IO operation. IO operation and expensive, right? So if you are keep writing into the transaction log file, this can impact the performance of your execution because we are doing so much IO operations, right? So to avoid that, what happens? The SQL Server internally maintains a some memory area, we call it as log cache, where the data is written to the log cache first. So from this log cache, asynchronously, it will write into the transaction log file. What is asynchronously? It will not wait. The transaction, no operation would be waiting for this writing into the transaction log file. So from the log cache, it will write into the transactional log file. Whatever data that we have in the log cache, it will write into the transaction log file. So this is what we call it as durability, right? So we are make sure that data is available in the transaction log file so that even if there is a crash happen, then the data can be recovered. We would be able to recover the data, right? So we have a different recovery phases. I'm not going to talk all, like that is the basic. And recovery phases, like, so analysis, redo, undo, whatever, like the phases that we have. So we will have to, this happens because we have enough data available to recover in the transaction log file. Now, so when this log cache data will be flushed, there are two scenarios. One, the log cache size is full. I think the log cache size by default is around 64 KB, for example. So if the 64 KB is full with your transaction, then it will flush that 64 entire KB, entire 64 as a chunk to the transaction log file, right? So as soon as the 64 KB is full, then it will write that complete chunk into the transactional log file, right? Or let's say, for example, you are doing a short transaction. Let's say, for example, the transaction size is around 4 KB. It generates a 4 KB logs, but the transaction is completed, right? So begin run and commit run, done. The transaction is completed. Then immediately write into the transaction log file. If the transaction is committed with respect to whether the size is reached or not, the data will be written to the transactional log file, even if it is 1 MB, 1 KB, or even, so 2 KB, 3 KB, doesn't matter. Even if it is not reaching this limit, it will write into the transactional log file, right? These are the two scenarios. It will write into the transaction log file. One, if the log cache size is reached, that is 64 KB is reached. Second one is if the log file, so if the transaction is completed, and it will write into the transaction log file. So these two scenarios, it will write into the transaction log file. And what if you keep writing into the transaction log file? What if you just a short transaction, like you are keep committing the transaction, it will keep writing into the transaction log file. So you'll again see that IO operation. For that, starting from 2014, we have one feature called delayed durability. Delayed durability. So what does it mean by delayed durability? So whether the transaction is committed or not, until and unless it reach this max limit, it will wait in the memory itself, right? So even if the transaction is committed, the transaction data would not be written to the transaction log file until it reaches this limit. If you enable the delayed durability, so even if the transaction is committed, right? So until and unless it reaches this 64 KB of size, it will not write into the transactional log file. Now, can anyone tell me whether this feature is good to enable or not? If yes, why? If no, why?
I would say it's not good.
Hmm.
That will be because if there is a disaster, if a disaster occurs, you would lose all the data that were not written to the transaction log file.
Hmm. Exactly. Right. So this is not the recommended one, right? So that is the reason, like, we by default it is not enabled, and we also don't enable until and unless this feature is really needed. But yeah, your good point that if the data is not available in the transaction log file, then you would not be able to recover, right? If you enable the delayed durability, even the transactions are committed, the data would not be flushed to the transaction log file. If that is the case, if there is a crash happen or disaster happen, your SQL service is restarted or SQL service is stopped, whatever data which is there in the memory is gone, right? So you would not be able to recover that. So that is the reason. So we should not enable. This is just a feature that I just mentioned, so we have to overcome this high IO operation, but you will end up seeing some data loss even if the transaction is committed. So that is the reason it is not recommended to enable this feature, right? Cool. So that is how that works, right? So the transaction manager, you have something called lock manager. Lock manager, we will talk details about the locking, lock, block, that latter part, right? So this is how that works, right? And when this data will be, now I was talking about the dirty pages. So give me around mostly around 5 minutes. I'll just wrap up. I know it is almost late, but yeah, just give me max 5 minutes. Okay. So now we have this data, right? So we call this as dirty. So when this data, when this page is considered as a clean, right? There are two operations. One is checkpoint. Second one is lazy writer. So what is checkpoint? Checkpoint, so it keeps checking if there are any dirty pages. The default interval is 1 minute, 60 seconds, whatever, so if it is a default checkpoint, automatic checkpoint, right? So 60 seconds, it checks if there are any pages in the memory which are dirty, right? So which needs to be flushed to the data file. So then what will happen? This will be, you can consider it as a copy of your dirty pages, and it will write into the data file. And if these two are same, this is considered as marked as clean page, right? But the page would still be available in the memory. That is the checkpoint. Checkpoint, you just flush the data pages from the memory to the data file, right? So the page would not be removed from the data, page would not be removed from the memory. Page still be available, right? So that is how the checkpoint, that is what checkpoint is, right? Checkpoint, it will flush the dirty pages from the memory to the data file. The common misconception with the checkpoint is checkpoint will flush only the committed pages, right? Let's say, for example, the transaction is committed and it is marked as dirty. The checkpoint is flushes only the committed page to the data file. That is the misconception. The actual thing with respect to the transaction is committed or uncommitted, checkpoint will flush the pages, dirty pages to the data file, right? So with respect to whether the transaction is committed or uncommitted, checkpoint will flush the pages from the memory to the data file, so that whenever there is a crash happens, you should be able to recover the data, because the same information will be stored in the transaction log file. Even it is a committed or uncommitted, that information is stored in the transaction log file. If there is a crash happens, with the help of transaction log file, the data pages which are there in the data file would be rolled back to its previous state, right? So that is the reason with the transaction is committed or uncommitted, the checkpoint will write the pages into the data file. Second thing, lazy writer. If there is a memory pressure, or let's say, for example, I was talking about 1 terabyte database, you have only 100 GB. How that is possible, right? 1 terabyte database, you cannot have 1 terabyte database, right? So you no need to have 1 terabyte database. Within 100 GB, you should be able to sustain the SQL service, right? How is that possible? Because of the mechanism called lazy writer. So lazy writer, if there is a 100 GB pages are stored in the memory, then it needs more pages. It needs more memory to accommodate the pages from the disk. Then lazy writer, what it does, it start removing pages from the disk. it remove pages from the memory, right? So it checks what are the least recently used LRU algorithm, and it checks that whether the pages are recently used or not. If not, then remove all these pages from the memory. Even if none of the pages are recently used, it will just have that some internal calculation, and it removes the pages from the memory so that it should be accommodate some space to the other data pages which is reading from the data file, right? So that will take care by the lazy writer. Lazy writer will clean up the memory, that is your data cache, by removing pages. What is the difference between checkpoint and lazy writer? Checkpoint will not remove the pages from the memory, but lazy writer does remove the pages from the memory to clear or to accommodate other pages, right? To clear memory, it will remove the pages from the memory, right? But lazy writer does not. Right. So any questions? That these two are that is required, like it will remove from memory and it will accommodate, it will allow pages to be accommodated in the memory itself, right? So I believe I covered. So any questions?
I have a question.
Yes.
Back to the optimizer phase.
Mhm.
I was just thinking because I recall that at the optimization process, that's when it checks if it's a new query, right?
Hmm.
It would create the plan. And if it recognizes like it's an old query, it will go and check the plan cache.
Correct.
And my question is, why is there no arrow that connects the optimizer phase to the plan cache?
Up to there is no arrow, right? So it doesn't, right? So it doesn't have that. This is just a diagram that we have, right? So we
Yeah,
don't
I
have
know.
any.
But is my understanding correct? Like there should be something, right? Like at the optimization phase, that's when it checks if it's a entirely new query and it has to create a new plan, or it goes to the plan cache if it recognizes it as an old query or something that has been run before.
Correct. That is true. So why there is no arrow, like so this is what I have that diagram, but it will not go again, right? So if there is a access method, storage engine and all, if there is a query or executor, right? So again it will go to the storage engine, but to be frank, like so storage engine, and from there it checks, like so the plan is available or not. Plan is also stored in the storage engine itself. It will not directly go and communicate. It will just go to the access method and storage engine, and from there only it gets the plan from the query that is required. But the arrow we don't have, so maybe some internal structure it takes care of. So that is where we don't have, because we have every query, we require some hashing. So even plan, if you're executing, it needs some hash, plan hash. That is the internal memory structure. So based on this, we have something called hash buckets. So this algorithm, hashing algorithm, it follows. So whenever a query is generated or whenever a query is going for execution, so the query plus query hash. So query has query hash, and this query, it identifies whether I have a proper hashing for the plan as well, right? So this plan also will have that plan plus query hash both, so that it identifies this query is for this plan hash. So that is a hashing algorithm. Internally, it checks so that it identifies the plan that is required, the plan is related to this particular query based on the hashing algorithm. So there is some internal algorithm, it takes care of that. So that it will identify, okay, this hash algorithm, I have this plan. So that will take it. That is the reason I have not mentioned, we don't have any, so arrows here, right? It based on the some internal algorithm it follows, right? So it is just a kind of function or algorithm that you consider. It checks that hashing, whether the hash is available. Okay, then it will go to this particular plan and pick that plan that is available. That is the internal structure it follows.
So this thing happens before the query execution, right?
Correct.
All these things you mentioned, it happens just before the query executor phase.
Correct.
All right.
Even query generation, plan generation also, it happens even before generating a plan, it has this hashing, right? Every query has hash, right? If I take this, I'll take just a minute. If I take this, right? Select start from sys.dm exec request. Don't worry about this. I will show where session ID is greater than 50, right? If I take this plan handle, SQL handle, right? So these are considered as a unique hashing algorithm. So it identify, okay, this query. So each query will have that each, so handle, and this query has this handle, right? So that it will internally calculate this query is for this plan, so that the plan will be picked up. That is called hashing algorithm. It follows internally in the memory itself. Okay, cool. So any questions? Did it clear? Did I clear?
Yes.
Okay,
Thank you.
cool. Okay.
Sorry,
But yeah, so
Chandu, we are getting late.
yeah, I understand that, Pankaj. So that's what, like, I am almost done, right? So whoever getting late, maybe you don't have any questions, maybe we can disconnect. We are already done. So this is just a questions part, and if you have any questions, we can talk.
So the lazy writer is in performance monitor is one of the things used to check if there is memory bottleneck or not, right? But from the way you explain it, lazy writer, if there are so it's kind of writing the dirty pages to disk, right? But when the lazy writer value is very high, it's one of the indicators of a memory bottleneck. So I'm trying to understand that concept, right? So is it not desirable to just keep on writing this dirty pages to disk, right? This is what we want to achieve. Is that correct? So no.
Correct, right? So okay, memory, I mean, so memory we will definitely discuss, but if you're asking only the lazy writer part, so lazy writer,
Yes.
definitely, if there is a high lazy writer, there are two things. One is there definitely memory pressure, because you don't have enough memory to accommodate the pages, right? So second thing, let's say you are doing huge operations, right? So either it is a read, write, whatever operation that you are doing, huge operations where you don't have enough memory, right? So enough RAM or enough memory to accommodate the pages which are processing, right? So that also can be one of the reason that you might see that lazy writer is high. So in that case, if lazy writer is the first part that we will have to check if there is any memory bottleneck or not. If you have a high lazy writer, so it can be a memory pressure, or it can be you don't have enough memory to accommodate the pages. There are two things, right? Memory pressure is different, and you don't have enough memory to accommodate the pages is different, right? Memory pressure, because some other memory areas, memory components are taking up most of the memory, right? For example, plans. We will talk more in detail about memory and all. Just for your information, like you have a data cache, you have a plans. Let's say, for example, plan is taking up 40 gigs of memory, whereas database, you have only 60 gigs to accommodate. 40 gigs is taken by other memory part, right? This is the memory pressure. But let's say you have given 100 gigs, whereas 98 gigs or 95 gigs, even 90 gigs is only for the data pages. Then this is not a memory pressure. You don't have enough memory to accommodate the pages. So you will start seeing that lazy writer high, because you are doing so much operations where you don't have enough memory to accommodate the pages, right? So that is where we will have to start looking into what operations that we are performing and how much data we are reading, and whether it is actually a memory pressure or not. So we will talk in detail the memory in memory architecture.
Okay, thank you. But so from your experience, when building a server, right? what parameter do you usually decide how much memory to use on the server?
You mean how much memory to use or how much memory is being used?
No. So you're building a new server, right?
New server, okay.
Yeah. So when building a new server, how do you size your memory based on
Correct. No.
based on
Yeah. So normal recommendation would be around 75 to 80% of the system memory, right? Suppose if you have a dedicated machine and if you have a SQL instance installed and if you have 100 gigs, like around 75 to 80 gigs of memory based on the, so even Microsoft are based on the recommendations that we follow. Around
Sorry,
75
I'm
to
not
80.
talking about the maximum memory allocation. Yeah. What I'm talking about is you are trying to decide your hardware resources when you're building a new server, right? And you want to decide, are you going to go for, say, 32 gigabytes of memory or 64 GB of memory? Do you, how do you make this decision? Is it based on the number of, the size of the disk? Probably you're expecting, say, 1 terabyte of disk, and then you will decide to go like memory to be like at least 10% of the size of the disk, or from your experience, how do you usually make that decision?
So okay, so definitely not, because we don't have that such so thumb rule to configure the memory and based on the disk, because I came across like so even we have 12 terabyte database, like where we have only a few gigs of database, few as in like around 500 or even 700 gigs of data, 700 gigs of memory. So definitely not. It all depends on so the complete compute size, and yeah, it also depends on like so what operations that we're performing. So we don't have thumb rule, right? So maybe you can consider that 10%, but 10% might be more or less in some situations, right? For example, let's say you have a 1 terabyte and 10% is would be 100 gigs, right? So just an example, but it might be more or less. That all depends on the workload that we are performing, so we are processing. So that is the reason there is no uh, thumb rule that we will have to follow this calculation to have this memory or not. So we'll have to have that basic memory at least, so 100 or 64, even 64 I have seen, like even terabyte databases, right? Like let's say for example you it all depends on what operations that we are performing, and based on that we'll have to scale up the memory resources as needed. That's it. That is what I can tell, right? Based on my experience, I have seen different environments where the people are using like even 1 terabyte, even so even 100 or 60 gigs of memory. But it doesn't matter like what database size that you have. It all depends on the workload that they are processing.
Okay, thank you.
Sure. Okay, so any questions? We are all almost over you.
Yeah, Chandu. Can you please explain me what happens after the transaction log gets committed there? Like after.
So after the transaction log get committed as in?
Can you please explain what happens after the transaction, the access method? After the access method, it will share the data to transaction manager, right?
Correct.
To that, can you please explain a bit more after that process?
Sure. So we have something called log manager. So log manager, that's what I was showing here, right? So with respect to whether that this is considered, you can consider that is an update, insert, update, delete, whatever we are doing. So you can consider this log manager, which will write into the log cache. I mean, so it will first write into the transaction log cache internally, and the log manager, which will flush this log cache data into the transaction log file. So whatever data whatever operation that we are performing, so it will write, the log manager will take care writing the transaction information into the transaction log file. Whether the transaction is committed or uncommitted, it will keep writing into the transaction log file based on the log cache size that we have. So we have something called log cache, and from this log cache, it will flush the transaction data into the transaction log file. So once the transaction log file, so writing, and if you issue a commit transaction, so this is where like it will write that commit information into the transaction log file, and it will release that logs which are held by the log manager and releases the logs, right? So
okay, if you're not committing it, will roll back, like it will clear up the log.
What is that?
If you're not committing, then
if you're not committing, it will what is your question? If it is not committing, So you mean that if it is not committing, it will not release the locks, you're asking, or what exactly the question?
What happens like if it is not coming? I just want to
So
understand.
if it is not committed, let's say the transaction is keep open. If it is open, the locks will be not released, and you will have that other kind of so blocking and all. But it doesn't have anything to write into the transaction log file. So let's say, for example, your transaction is explicit or implicit, whatever. Begin transaction, and you are writing whatever data that you have, that update, insert, delete, whatever you have done, and you have not committed the transaction. So if it is not committed, whatever data which is written, it will write into the transaction log file. So, but the transaction log file, that is a different story. The transaction log file will not be truncated until and unless the transaction is committed, right? The transaction log file will not be reduced. It will keep growing, right? Because you'll have some active VLFs and it will not be committed. It will not be truncated. That is one issue. Second issue, it will not release the locks. If the locks are not released, then if you're trying to access the same resource, and it will be blocked. There are two issues. One is your transaction log file will keep increasing. Second one is your logs will not be released. It will leads to blocking and other isolation. I mean other transactional issues. Is that what you are asking, or something different?
Yes.
Okay.
So if it is not getting these two other scenarios, if it is committed, then what is the next procedure?
If the transaction is committed, the commit transaction information will be written to the transaction log file. So as soon as the commit information written to the transaction log file, so then it will check, like, so like a checkpoint happens, right? Checkpoint, it will write into the data file. So it will communicate with each other, the checkpoint and transaction log file, and see whatever transactions which are committed here, whether the database has that information or not, the data pages or not. If that is the case, then it will go for, so truncate the VLFs. So if once the VLFs are truncated, then, so the new VLFs will be created. So the VLFs will be truncated in the transaction log file. That is the transaction log file architecture, right? You'll have the transaction log file, and if the VLFs, and if the if the transaction is open, then the VLF is considered as active. If the transaction is committed, the VLF is marked as inactive, so that it will be, it can be truncated. But the truncation part is where, like, we perform multiple, like, different things, right? If it is a full recovery model, that DB's, I mean, backup log, transaction log backup will truncate the transaction log file. If it is simple recovery, like that is where, like, so you have some 70% or some log file, then it will go for truncation, the transaction log file, if it is committed.
Okay, thanks.
Sure. The reason that it will wait for the pages to be flushed to the data file, because if it is truncated, let's say, for example, the transaction log file is truncated, and if the checkpoint has not written the data file, data pages to the disk, what will happen, right? So you will have the inconsistency. You cannot roll back if there is a crash happens, right? So that is the reason the truncation would have to wait for the checkpoint to flush the pages to the data file, right? So truncate will truncate only if the page is marked, a page is available in the data file, because even truncate, every LSN will have the page information and the transaction information. So it will identify the page is written to the data file, and based on that, it will truncate the transaction log file.
Okay, thanks.
So any questions?
So I have one question. Because you mentioned transaction log truncation, I've seen a situation where we're trying to truncate log file, and it was not happening. So what would be the possible reason?
So if the truncate is not, okay, 1 second. If the truncate is not happening, it must be waiting for some resources. So what it is waiting for, that we will have to look into. So where we can check, like sys databases, that where we can check.
Okay.
Log reuse wait description, so that you will understand what is the reason for not able to truncate. Okay. So log reuse wait description, it. It tells that what is the reason for, so what is the reason for waiting? Like, for example, active transaction. So if there is an active transaction, then we can consider that VLF is active. So VLF is active. If the VLF is active, then the lock would not be truncated. So you'll have to check what it is waiting for.
Chindu, while executing this query, if it is showing an active replication means, what is the scenario of that?
So availability replica, because
yes.
transaction, whatever we are performing, so the secondary is not able to commit or not able to harden, like whatever, like not able to receive the data. The data which is pending, the secondary to be received. So until and unless secondary is received, then your transaction would not be, the transaction log would not be truncated. Yeah. Why secondary is not receiving? That is what we'll have to look into. Like locks and queue, if there is a locks and queue, or if there is a read queue, or anything is high, then that is where the transaction log will wait for secondary to be clear up those transactions.
What if you turn on ADR?
Turn on ADR what? So turn on ADR, yeah. So turn on ADR, so it will keep truncating the transaction log file with respect to whether the transaction is committed or not. So while recovering, so it has to read from the like we have something called snapshot, like so we have something called so it will be reading from the disk, right? Versioning, and it will be reading from that versioning and the disk. So that improves the recovery rate, right? Recovery speed, right? So you, while recovering, because earlier we used to recover or read from the complete log file from the last checkpoint, right? So now if you have a ADR, so the undo would be much more faster, because you don't need to so scan the entire transaction log file, because we have something called versioning and all, like it will read from the version itself instead of reading the complete log file. Okay. Any questions? Right. So if you don't have any questions, I'll stop here and we'll connect tomorrow.
Thank you, Chandra.
Thank you. Thank you all.
Thank you. Good night.
Thank you.
Yeah.
Thank you.